In this video, we're going to look at several different ways of factoring polynomials. The first we're going to look at is GCF factoring. GCF stands for the greatest common factor. The greatest common factor is the biggest number or the biggest monomial that goes into every term in your polynomial. So if we look at 9y cubed minus 6y squared plus 3y. First, we can start by looking at the numbers, 9, negative 6, and 3. The greatest number that goes into all three is a 3. If we look at y cubed, y squared, and y, the greatest variable that goes into those is just y. It's always going to be the smallest exponent. So in this case, we have a y to the first power, so that's our common factor. So our GCF for this entire polynomial is 3y. Once you find your GCF, you're going to pull it out. So we're going to put a 3y on the outside, and then on the inside, we're left with 9y cubed divided by 3y, so you get 3y squared, negative 6y squared divided by 3y, to get negative 2y, and 3y divided by 3y to get positive 1. So factored form is 3y times 3y squared minus 2y plus 1. You can always check your work when factoring by multiplying back out. So to multiply, all we have to do is distribute. And when we distribute, 3y times 3y squared is 9y cubed. 3y times negative 2y is negative 6y. And 3y times 1 is 3y. We're back where we started, so we know that this is the correct factored form. You can work on this one by yourself, so go ahead and pause, work through it, and then I'm going to continue and work through it, and you can see if you get the same answer. If we look at 24, negative 18, and 18, our GCF is 6. 6 is the largest number that goes into 24, 18, and 18. If we look at b cubed, b squared, and b, our smallest exponent is b to the first. So our GCF is 6b. So if we pull out a 6b, 24b cubed divided by 6b is 4b squared. Negative 18b squared divided by 6b is negative 3b. And 18b divided by 6b is positive 3b. So our factored form is answer choice C, 6b times 4b squared minus 3b plus 3. Another way of factoring that involves GCF is factor by grouping. So all you're going to do when you factor by grouping is divide your equation in half. Grouping works when you have 4 terms to factor. If we look at just the first half of our equation, we're going to pull out our GCF. So our GCF between 8a squared and 10ab squared is 2a. 2 is the biggest number to go in 8 and 10, and our smallest variable that's in both is a to the first. Then we're going to pull out that GCF. So we have 2a, that leaves us with 4a plus 5b squared. Now we're going to do the same thing for the second half of our equation. We got 4ab and 5b cubed. Our GCF is just b. That's the only thing that goes into both 4ab and 5b cubed. So we're going to pull out a positive b. That's going to leave us with 4a plus 5b squared. The trick to grouping is to make sure you have the same thing in both sets of parentheses. So if we look at our parentheses, we've got 4a plus 5b squared and 4a plus 5b squared. Now that we know we have the same thing, we're just going to rewrite our equation. We're going to put whatever's in parentheses, so 4a plus 5b squared. And then our second set is going to be this 2a plus b. So factored form is 4a plus 5b squared times 2a plus b. You have to make sure your parentheses are the same. If they're not the same, you may not pulled out the correct GCF, or you may have to manipulate your negatives and positives. You can always check your work by multiplying it back out. So for this one, we'll FOIL. So we do 4a times 2a to get 8a squared, 4a times b to get 4ab, 5b squared times 2a to get 10ab squared, and 5b squared times b to get 5b cubed. And this is the same exact equation we started with, except 4ab is in front of 10ab squared. Just like before, go ahead and pause and work on this one to see if you get the same answer as I do. So if we divide our equation in half and look at just the first half, right, we got 6p squared minus 3p r squared. Our GCF is going to be a 3p. If we pull out 3p, we're left with 2p minus r squared. If we look at the second half of our equation, we have plus 8pr minus 4r cubed. Our GCF is going to be 4r. So if we pull out a positive 4r, we're left with 2p minus r squared. We know that we're doing something right because we have 2p minus r squared in both sets of parentheses. So that's going to be our first set down here. Our second set is going to be our 3p and positive 4r. So our answer is D. The final way or factor we're going to look at in this video is difference of squares. You should have seen difference of squares before, and it's just like what it sounds. You got to have a difference, so you got to have subtraction, and you've got to have perfect squares. Perfect squares are the numbers that we can take the square root and get integers. Okay, so if we look at our example, x squared 25, and we have a difference. The square root of x squared is x. The square root of 25 is 5. So then we just plug it into our pattern of x plus 5, x minus 5. It's just a pattern you have to memorize. Note that x squared is a perfect square. Any variable with an even exponent is a perfect square. The square root, you just cut it in half. So for example, the square root of x to the 10th is x to the 5th. So any variable with an even exponent is a perfect square. Our second example, we've got 12b to the 8th minus 27c squared. Well, b and c both have even exponents, so they're perfect squares, but 12 and 27 are not, as of now. The first step in factoring is to always look for a GCF. So if we look for a GCF, our GCF between 12 and 27 is 3. So if I pull out a 3, we're left with 4b to the 8th minus 9c squared. And now we have difference of squares. The square root of 4b to the 8th is 2b to the 4th. And the square root of 9c squared is 3c. So now don't forget about your 3 out front. That's still part of your answer. So we have a 3, then 2b to the 4th plus 3c, 2b to the 4th minus 3c. Your first step is always to look for a GCF. Our last example, go ahead and work it out. See if you can get the same answer as I do. Looking at 18d to the 6th and 50f squared, as of now, I don't see perfect squares. Our variables are okay, but 18 and 50 are not perfect squares, so we have to look for a GCF. Well, in 18 and 50, 2 goes into both, so our GCF is 2. If we pull out a 2, we're left with 9d to the 6th minus 25f squared. 9 and 25 are perfect squares. The square root of 9d to the 6th is 3d cubed. And the square root of 25 f squared is 5f. Don't forget about the 2 out front. So we have 2 times 3d cubed plus 5f times 3d cubed minus 5f. And that goes with answer choice B.